Okay, so today in calculus we're going to talk about section 2.1. And in 2.1 we talk about the derivative of the tangent line. And the derivative of the tangent line is very important because it shows up lots and lots on AP tests, as Mr. Reamer will tell you. So in this section 2.1 we're going to do problem number 19. And in this problem, the part A asks you to find the equation of the tangent line at the point given. So the function f of x is equal to x cubed. And the point you are given is 2a. Now, to start off to find the point, the tangent line, you're going to try to get it in the form of y equals mx plus b. Now, to find the slope, which is m in this situation, you're going to want to use the derivative. So to use the derivative, you take f prime of x equals this. Now the derivative, we're going to use the power rule. So you drop the 3, then you have the n minus 1, which gives you 3x squared. So this is your derivative. Now, to find the slope at the point given, you're going to want to plug in the x value that you were given. So to do this, you take f prime, which is the derivative of 2. And that gives you 3 times the quantity 2 squared. Now you do the arithmetic, you have 3 times 2 squared, which is 4, and that gives you a slope of 12. This is the slope of your new tangent line. So you have y equals 12x plus b. Now this is where you have to come in and use your point again. To use your point, 2, 8, to find the b value right here, all you do is plug it in. So y equals 8, and then the x value is 2 plus b, which is the variable you're trying to solve for. So you just do the arithmetic. You have 8 equals 24 plus b. Solve for b. Subtract 24 from 8. b equals negative 16. That is your b value for the equation. So your equation, if you put it all together, you know that 12 is your slope. You know that negative 16 is your b. You get y equals 12x minus 16. This is your answer to part A. That's the equation of the tangent line. Part B says use a graphing utility and graph the function of the function, which is x cubed, and the tangent line. So to do that, just draw it on, it's your axis going. You have your standard graph of x cubed, which is a simple up and around. Now, in this problem, you're given that at the point 2, 8 is where you're trying to find your point of tangency. So you know that at point 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, you know right in this area is where your point of tangency is occurring between this line and that graph. So you know that if you went down 16, if you extended the graph all the way down to here, this is your intercept, and you know that on this line of tangent, it goes all the way down to negative 16. That shows that that is the point of tangency because that's the tangent to that line. Part C, so this right here is your answer to part B. This is what your graphing utility would give you. Now in part C, it says to confirm, use the derivative feature of your graphing utility to confirm your results. All you would do is go on your graphing utility calculator and you go to the math button and you'd find the end derivative button. This is basically a derivative solver. Right here you'd find that, you'd hit enter and you'd plug in x cubed because that's your original function. This will give you the derivative in the calculator. Now you do comma x, and then because that will give you the x value because that's the value you want, and then you do use 2 because that's where you want the point at. So if you do that, it'll give you an answer right here of 12. This will equal 12. Because this is where at the derivative of x cubed at x equals 2 is 12. That's what it will give you. And that is 2.1, number 19.